So here we go for this first one. So the first problem is asking you, what does the variable c represent? And what you want to do before you even get into problem solving is just identifying what everything is talking about. And of course, the instructional video that I'm doing is not working. Okay, there we go. All right, so here's what we're looking at, ladies and gentlemen. Before you solve anything, you want to identify what everything is talking about. So b minus 3 represents the number of cards. Everybody with me so far? Your next thing is a is going to equal the cards per person. I'll have to find a different writing implement. So now the question is c has to represent the number of what? Excuse me? What do you think c has to represent? If b minus 3 represents the cards and a represents the number of cards each person gets, what does c have to represent? The players. So before we even solved the problem, only thing we did was what? Organize and create visuals. Everybody with me so far? Now that you've created a visual, what is it asking you to do? What does the variable c represent? So what's the correct answer, ladies and gentlemen? A. Was this problem necessarily difficult? Not necessarily difficult, but what you want to do, like I said before, again, you don't want to try to problem solve on your head. Let me see if I can use a better instrument. Okay? Question number 2, the first thing we want to do is let's just organize what they're talking about. So we know a couple of things. 50 kind of represents the kits from the previous year. I'll just abbreviate kits from the previous year. The function that we have is what? 12b plus 32. That's our function, okay? So now let's take a look when we're reading this aloud. One of the things that we notice is as follows. It used to be what? 12 kits per box. That's last year's model. How many kits per box are in this year's model? 8. So 8b plus 32 is going to be our new model. So is everybody with me so far? The only thing we've done is just organize this stuff. So let's see what we're dealing with when we use our old numbers. Our old numbers are what? 12 times 50 plus 32 equals what? 632. So that means this is the total that we're trying to get. But that's based on last year's model. We have to use this year's model. So we set this year's model equal to 632. Is everybody with me so far? Now we've got what? An algebra problem. We subtract what? Remember in algebra, what you do to one side of the equation, you do to the other. So if we subtract 32 from both sides, we have 8b equals 600. And then in order to solve for b, since this is a multiplication problem, what's the opposite of multiplication? Division. So we divide both sides by 8, we get b equals 75. But is this our answer, ladies and gentlemen? No, because we have to find the difference between the two in order to figure out, the number of extra kits they need. So a 75 is based on the new model and 50 is based on the old, we get a result of 25. That is actually your answer. This one's a little bit tricky because they give you the old model, but you have to figure out the new models. Everybody with me so far? And then you solve based on the old model, but the new model, you're still trying to get to the same outcome. Everybody with me so far? So this is where it's more of a how many steps problem because it's multiple steps. And then 75 is what our value is for B under the new model. 50 is our value for B under the old model. And we find the difference. This is basically how much we have to get or how much we have to account for. Does that make sense to everybody in here? So if you got it wrong, do you see where you may have made your mistake? And again, don't panic about making mistakes. Quote, you want to mess up now so you don't mess up later. Okay, did everyone get a picture or whatever, what they need? Because I'm going to go ahead and clear this and go to the next one. Okay, let's go to question number 3. The key is this is not drawn to scale, but it's okay for you to draw this again. Remember what I said, don't try to do these in your head and create some type of visual. So here's one triangle, which if you picked it out, CAT spells what, ladies and gentlemen? Cat. So we're comparing a cat and a dog. How many of you peeped that when you were doing that? Raise your hand if that was you. Raise your hand if you're just raising your hand so you don't get called out. I know, bad joke. Ha ha ha. We can laugh a little bit. Okay, so here's what we know. So here's what they tell us. TC is similar to GD, and that ratio is 2 to 7. Everybody with me so far? The most important thing, though, is look at what they're asking you to find. We have to find something that has a similar ratio to this. Is everybody with me? So let's go through our choices. CA compared to DG, well, those aren't even, quote, corresponding sides, so we can disqualify choice A. Everybody with me so far? Let's look at the next one. Angle C and angle D. These are corresponding angles, which means those angles are probably going to be the same measurement. And we're looking for something that gives us a 2 to 7 ratio. So we can disqualify choice B. Everybody still with me? Let's look at choice C. Area of CAT to DOG. Do you really think that's going to give us the ratio that we're looking for? It is not. So we're left with D because, again, if it's looking at the ratio of the sides, and the sides in D are corresponding, therefore they're going to have the same ratio. Does that make a little bit more sense for number 3? In the event you got it wrong, or you just guessed because you just kind of forgot what you were doing. If you kind of forgot what you're doing, that's okay. But do you see what we did here, ladies and gentlemen? Okay. Let's clear this one out and look at question number 4. Number 4 is one of those that's a little bit tricky versus difficult. So here we have all this stuff under the square root symbol. And our goal is when we come out of this, we have a perfect square on the outside. Everybody with me so far? So let's look at the coefficient or the number in front of the variable, 16. Is there a number we can multiply by itself that will give us 16? 4. Okay, so we're good so far. This is where it gets tricky. Because remember with exponents, you're basically adding or doubling the exponent. So is there an exponent or number that we can double up that will give us the number 9? Is there one? If we add it together, we're not multiplying, if we add it, that's the key. Is there a number that we can add to itself that will give us 9? No. So here's what has to happen. Under the square root, we have to, this is what they won't tell you. We're going to separate this to make this x to the 8th, x, and then y over 6, because we know x to the 8th times x to the 1st will give us x to the 9th. Is everybody with me so far? Because remember, we multiply with exponents, we add. Is there a number that if we double it will give us the number 8? What is that number? 4. So we have x to the 4th on the outside, and let me erase this right quick so I don't get it too messed up. So we have x to the 4th on the outside, but inside the square root we keep the variable x, because when we put x to the 4th inside, it'll be x to the 4th, which is x to the 8th, x to the 8th, and x to the 1st will give us x to the 9th. Is everybody with me? The variable y, is there a number that if we double it or add it to itself will give us the number 6? 3. So our answer is going to be 4x to the 4th y to the third times the square root of x. If you got it wrong, don't panic, because the difficulty on this is remembering your rules with exponents. That's the trick on this one. Does that make a little bit more sense to everybody? So if you got it wrong, do you see where you made your mistake? And hypothetically speaking, if you saw this type of problem again, do you feel like you're in a better position to solve it? Okay. Give people a little bit of a minute to kind of copy, record, all that type of thing, and then we're going to look at question number 5. Yes?
I don't see them. Yeah, I don't.
Which of the following expressions is equivalent to question number 4?
Yeah, I don't.
Right there.
No, I'm talking about the answer.
Oh, so the answer is x to the 4th, y to the 3rd times the square root
Okay,
of
so
x.
it is
It was
D.
D.
Okay.
Yeah, I just kind of wrote it in the order that I was
Okay.
separating it out. But yes, the correct answer is D as in David. Yes, ma'am.
Okay.
Okay, yeah. I when I was solving it, I separated it out, and then you just have to look at what matches. But no, you brought up a good point. Okay, let's look at question number 5. Okay, question number 5. The trick on this one is, look, you have 2 lines, which means you have to do the linear equation twice. You have to do the linear equation for the line on the top, the linear equation on the line for the bottom, and then you set both equal to each other. Is everybody with me so far? So we look at number 5. It looks like for the line on the top, the y-intercept is 8. And it looks like the slope is -1/2. So remember rise over run and all that stuff? So for the top one, we're just going to have y equals -1/2 plus 8. Does everyone see how we got that for the slope for the top? Okay. Let's look at the bottom. For the bottom, it looks like the y-intercept is -2. And when we do the slope, the rise over run, it's a +1/3. So our linear equation on this one should be 1/3, and I forgot to put the variable x, -2. So our top line is -1/2 x plus 8. Our bottom is 1/3 x -2. Does everyone see where we got those linear formulas from? All we did was find the linear equation for both lines. Now, this is where it is and it isn't difficult, because you know that you have to set these equal to each other. But the catch is this. Here's the catch. You don't want these fractions as your coefficients, because that's too messy. Like, how many of you know, without calling them out, how many of you know messy people? Raise your hand if you know messy people. If they're in this room, do not point them out, because whatever happens afterwards is not my fault. Everybody clear? So what we got to do is we need to find a common product. So if we use our denominators, 2 and 3, if we multiply them together, what's 2 times 3 going to give us, ladies and gentlemen? 6. So in algebra, what we do to one side of the equation, we do to the other, but we can put this entire problem in parentheses and multiply by 6. We're going to multiply everything we see inside these parentheses by 6. When we do that, we're going to eliminate the fractions, and then it'll be easier for us to solve, because it'll look like a regular old algebra problem. Everybody with me so far? So we multiply this out, and you have to remember your integer rules. A +6 times a -1/2 is going to be -3x. A +6 times a +8 is going to be a +48. A +6 times a +1/3 x is going to be +2x. A +6 times a -2 is going to be a -12. So this is the tricky part, because you got to remember your integer rules. Everybody still with me? Okay, now I'll create some space up here. I'm going to add 3x to both sides, because I don't like dealing with too much negative stuff. So when I do that, I have 5x minus 12 equals 48. So all I did was add 3x to both sides to get rid of the negative. Everybody still with me? I know I have to have all the numbers to one side and the variable and coefficient on the other. So if I add 12 to both sides, I'm left with 5x equals 60. And then in order to solve for x, as y'all pointed out earlier, if this is a multiplication problem, what's the opposite of multiplication? Division. So if we divide both sides by 5, we get x equals 12. Now the beauty of this problem is when you look at your answer choices, there's only one answer choice that has an x coordinate of 12. So B is going to be your correct answer. So this one is another example of how long ago and how many steps. Have y'all done linear equations before? Yes, you have. Have you had to solve the linear equation for 2 lines? You probably have. Have you had to set them equal to each other? You probably have, but it may have been a minute. And then with getting rid of the fractions, have you done that before? Yes, you have. Has it been a minute? Possibly. And then remembering your integer rules. Have you done integers before? Yes, you have. Has it been a minute? Possibly. Does that